and IPv4 header acceleration stuff in hardware today, you'll start to see IPsec acceleration for v6 because this is just really, really handy. It gives you an additional layer of security that you don't even really have today. I mean, technically, I guess you could do this in v4, but nobody does because it's just too hard. I think having it ubiquitously everywhere is going to make it much more usable. Of course, this also means that this stuff can be used for evil. Having encrypted packets can make deep packet inspection impossible, difficult. It depends on who's doing the encrypted and if you have the keys to that. But potentially, your packets are completely opaque. This can be used for a lot of evil. Think botnets and command and control that packets are just completely, you're blind to what's inside of them. How do you know if they're doing bad things or not? AH is hard to configure. AH is authentication headers. Basically, this is what allows you to set up two hosts to cryptographically authenticate each other. They know that they are who they say they are, which can help prevent spoofing and replay attacks and things like that. Right now, it's really hard to configure and maintain. I think in some cases it's not even cross-platform compatible. It will be eventually, though. I mean, it's in the spec, and there's only really one way to do this. And eventually you'll see, interfaces like LDAP and DNS-based configuration for this stuff so that it becomes naturally easy to turn on. I believe that soon you'll see it, integrated into things like Active Directory. So it basically just works, which is pretty cool. But right now it is difficult to use. IPv6 has a lot of potential to be used for backdoors, Trojans, command and control, things like that because of these security features. As I mentioned, packets can just be opaque, and you have a botnet that uses AH, for instance, to authenticate all of its botnet nodes as well as the command and control servers and stuff like that. To make it a lot harder for researchers that research that stuff to break into them, but also to take them over and mitigate them or turn them off. That gets really, really difficult. I mentioned NAT here, and it's not that NAT doesn't necessarily exist in v6, but technically right now there really is no NAT. There's no 6-to-6 NAT, and this has one big security problem that I can think of right now, other than the fact that it's NAT, and NAT causes its own security issues, and that's the PCI. The PCI spec right now stipulates that you must have NAT on your network. If you're taking credit cards or any of that kind of payment stuff online, you must have NAT. You have no NAT in v6 right now. There are some RFCs out there for NAT 6.6, NAT 6.4, and all this other stuff, but that's not really, I don't believe that any of that stuff exists on networks today, at least not in a production capacity. So if you have v6 only, you can't be PCI compliant, and I think they're going to have to update their spec to address that. That's a real problem. It's also, IPv6 addresses are really complicated. They're long, they're confusing, they have letters, they have numbers, they have colons. If you have bunches of zeros, you can chop them off, or you don't have to. It depends on what your preference is. Writing regexes for those, it's hard. Just reading those as a human is hard. The ability to type them in is hard. It's going to lead to errors in confusion and things like that. And just as a sysadmin, working with them is more difficult, which is going to lead to security problems because people are going to type them in wrong. And this is back to the dual stack. I mentioned dual stack earlier and how it can cause problems from basically a complexity standpoint. And this slide talks about that a little bit. If you have multiple stacks, you have multiple targets, you have basically multiple problems there. You have a single host that has a v4 address and at least one v6 address, maybe more. All of these need to be in the right access control lists. They need to be in the right firewall rules, all of that. They need to be monitored properly. That's really difficult to maintain across one protocol. It's even harder across two. And so maintaining policy for routing or ACLs, all that's very difficult. Applications, they lack feature parity. So you have an application that does function X over IPv4, but it doesn't do it over v6. So what do you do? And that can be as simple as listening on a TCP port. How do you fix that? So you have this application, you have a box that's dual stack, but the application that's running is only v4. How do you fix that? There's 6-tunnel, there's proxies, there's things like that, but then you lose logging. So how do you audit these connections? How do you know when somebody's abusing the service and things like that? It's a real problem. You have really the same problem with appliances. I mentioned the load balancers and firewalls and things like that. It's it's a problem that we have to wait this out. We have to wait for vendors to come in and help us fix this stuff. So what did we learn at ARIN when implementing this stuff? We learned a whole lot, and a lot more than really are listed on these slides. A lot more than we could probably talk about when we get into asking questions and things like that. But here's a few things. Tunnels are less desirable than native, and that's really just to do with MTU. There's ways to work around MTU problems. For instance, for a while on the Sprint circuit that we originally implemented, we just set our web servers to an MTU of 1280. That's the minimum MTU size you can have on v6, so path MTU discovery, all those problems just go away. But then you're kind of sending all these little packets around. It's not very efficient. Certainly less than ideal, and that was to mitigate issues with tunnels. If you can avoid tunnels, I would say do it. If you have to use them, then go for it. Especially right now, there are companies out there that will give you free IPv6 transit over tunnels. And if you're in Exchange, you can get a 100 megabit tunneled connection to some really good v6 providers basically for free. Some of these providers, they'll give you 48s. So you can set up, and route your entire network. You may not get a good SLA for that, but it's great for your lab and things like that. So, for experimental, use a tunnel. When you really want to deploy it on your network, try to find a provider that does it native. At least in our area, ARIN's located outside Washington, D.C., and things have really changed in the last 3 or 4 years. It used to be that I could barely find a provider that knew what IPv6 was. And I ask providers now, even little ones, and little ones to me are kind of the remarkable ones. I can call them oftentimes, and not only do they know what IPv6 is, but they want to sell me a circuit with no hassle. It's harder to get that out of Verizon or AT&T or somebody like that. Oftentimes I can say, oh, well, I'm with ARIN, and can we talk at DANOG or the member meeting, and I'll kind of go in the back door and I can short circuit that. I think you guys can do the same thing. You just have to make a whole lot of phone calls. It's a lot harder for you to find somebody there that will listen to you, unfortunately. But that's changing. I really do suggest that if the big providers won't help you, go to some of the smaller ones. They may be a few hops away from the core of the internet, but to get native v6 circuit, it may be worth it. Continue to route v4 over your primary circuit. Use another circuit for v6. That works really well, and I know people in the DC area anyways that are doing that through some of the smaller ISPs. Routing is not as reliable. This has gotten a whole lot better though in recent years. When we started doing this, the v6 internet was like the internet of 1989 or something. I mean, it was really, really horrible. Now I would say it's like the internet of maybe 1999 or 2000. You still have routing issues, but they're really few and far between, and I think a lot of the routing issues are actually related to growth more than people not knowing that their circuit is down or their router breaking or them running experiments during the middle of the day and things like that. It's usually because they're replacing equipment or they're having capacity problems on their old junky v6 router that they're using, and they're upgrading them. So yeah, things have seen a great deal of improvement there. Dual stack really isn't so bad. We feared this so much, and we haven't had any problems with it yet. Though you also saw our graphs, and we aren't really getting any traffic yet either. So we'll see what happens with that. I have a great deal of confidence that our firewall rules and things like that are good, and we're only letting the traffic through that we need to let through. So if we have an exploit there, it's really in some ways just as likely as it would be over v4 because it's probably an application issue anyways. Proxies are really good for transition. They're bad for logging, but they're great for transition. We use 6-tunnel to proxy, all sorts of non-HTTP services, especially. Things like WHOIS, the routing registry. Before we replaced some of these services with v6 native versions, we used 6-tunnel and some other home-built tools to make these TCP connections just work. We did lose logging, but we were able to get the services to work. If it's a web-based service, Apache makes a great v6 proxy, and you get full logging and all sorts of stuff with that. It works really, really well. I can't speak enough for how well it works. Squid also works, but we don't have as much experience with it at ARIN, but it's worth mentioning because I know that it works really, really well. Mentioned that native support is better. DHCP v6 is not very well supported. Our client network at ARIN has dual stack. It's v6 enabled. It's got v4. We have DHCP on v4. We use RA on v6. And the biggest reason for that is that most clients don't support DHCP v6 yet. If you have OS X, I have a Mac. A lot of people at ARIN have Macs. If you have a Linux box, it won't work with DHCP-v6 out of the box. You have to go do stuff to it. The only platform that I know of that you can just install and go is Windows Vista or Windows 7. And right now, we don't run any of that at ARIN. We'll probably have a few hosts that run it here by the end of the year. We actually have a lot of hosts that run Windows XP, and they are v6 enabled. And the way we do that is we use DHCP-v4 to assign them name servers, and they get v6 transit. It just works, but I should back up a little bit. Windows XP doesn't support DNS over IPv6. It'll do ping, it'll do TCP, UDP, all that stuff, but you cannot get it to do a DNS lookup over IPv6, which is seriously broken. However, if you're in a dual stack environment, it actually works just fine. So if you have this huge network of Windows XP boxes, you can actually dual stack them right now if they have v4 name servers that they can talk to. And that was a real boon for us, because that meant that certain departments at ARIN, we didn't really have to do anything to other than go to their boxes and turn on v6. It's very convenient. So I used to think Microsoft was stupid for that, but I actually think they were pretty smart. I mean, there's some technical issue that prevented them from doing that, but they did the best they could, and it worked really well. Bugging vendors does work. Brocade and Foundry are great examples of this, but gosh, Cisco, all sorts of people have been really good to us, and they've listened to us and given us the support that we need. I really do think that it works. It's a lot like bugging ISPs. If you bug them long enough, they'll start to listen. At ARIN, every RFP that we put out for equipment, bandwidth, whatever, it lists IPv6 as a requirement. We will not do business with you if you do not support IPv6. And that has gotten vendors to support v6 because they want to be able to put ARIN's name on their whatever it is, their website, their t-shirt, whatever, and say that we are a customer of theirs. In order for them to do that, they have to do v6. And it does work in our case. And I think that if you have enough buying power in your organization, it'll work for you too. You tell them you're going to go somewhere else, I'm going to use this transit provider, I'm going to use this vendor because they have better v6 support. They're going to listen to that. Their sales guys are going to cry when they lose that commission that they're used to getting from you. Security. Dual stack makes policy more complex. There's just no way around that. I mean, you have multiple protocols, and policy is going to be more complicated. The trick is to make sure that your policies are there's parity there wherever possible. Where there's not parity, it should be well documented. A good example of that is in ICMP. Make sure that you document why ICMP is allowed in v6 in certain cases and it's not in v4, so that future generations will understand that. IPv6 security features, as I mentioned, they're a double-edged sword. They can provide a whole lot of security, but they can also be used against you. And if your network is compromised, I fully expect to see Trojans and other things that go into networks via web browsers to start using IPv6, especially when you think that Windows Vista and Windows 7 have v6 turned on by default, and they'll even use Torito and other mechanisms to just tunnel it right out of your network. It's one thing to detect a v6 connection that's encrypted and it's native, where you can actually see it on the wire. Try doing that with Torito when it's inside a bunch of UDP packets over v4. It gets a whole lot more complicated. v6X are relatively untested. We talked about this before. There'll probably be some exploits. It almost seems inevitable. Maybe not, but hopefully they'll be minor, and it'll be a DOS kind of condition rather than UID 0 sort of exploits. But I mean, I think that'll happen. Somebody's going to have some bug in their code, and it will eventually get unearthed. This is a whole new world for hackers to explore, whether they're white hats or black hats. I actually think that's kind of cool. No matter what your thing is, if you're into compromising machines, if you're into securing them, this is a whole new playground to play in. It's effectively an entirely new internet, and I mean, what's more cool than that? Really, is something brand new, and we're right on the cusp of it happening. So, understanding ICMP v6 is an absolute must. You will break. I mean, I just can't say this enough. Fragmentation is very different in v6, and it's related to ICMP. Multicast is an attack vector. It's a discovery vector. It's also turned off by most ISPs right now, and I mean, much like it is in v4, finding multicast-enabled provider or getting your provider to even turn on multicast for you is difficult. It's the same thing in v6. The biggest difference with v6 is that it's used for neighbor discovery and other things. So it's very easy to write tools that will basically expose an entire network to you, or you can use that for real evil and use it to, for DOS attacks, basically, by using spoof packets and other things. There's ways to mitigate this. Using IPsec and AH, that helps.